Good afternoon, everybody. We're going to try to start on time, even though a lot of people are still running around. But, you know, when I used to teach, they used to say, if you don't start on time, then everybody knows you're not going to start on time, right? Okay, I'm going to start in about a minute. I don't want to delay too much because we do have a video tonight. And so, you know, we want a little bit of time between everything. Okay, well, I'm going to go ahead and start. So I'm honored to have been invited to open Strand 3 of this conference. My presentation, I will share the insights on community, climate change, and traditional knowledge from 3 Indigenous elders. The first interviewed elder is Dr. Mike Williams Sr. He is the chief of the Yup'ik Nation at Akiak, Alaska. He was the first person to chair the Kuskokwim River Intertribal Fish Commission and serves as one of its managers. The commission represents 33 federally recognized tribes on the longest free-flowing river in the United States. The Akiak community survives on subsistence fishing, hunting, and gathering. It depends on fish, marine mammals, and other species that migrate up the river from the Bering Sea. The community also hunts moose, caribou, and other mammals, and gathers berries, greens, and other edibles. The population is between 300 and 400 people. According to Williams, they are basically nomadic, going from spring camp to summer camp to fall camp, and not just residing in the community, but moving around to gather food. Recently, however, they have become more settled after their children started attending government-operated schools. Ed Johnstone of the Quinault Indian Nation is the second elder. He previously served on the Quinault Tribal Council and now chairs the Northwest Indian Fisheries Commission. The commission represents 20 treaty tribes in Western Washington. The White House under President Obama honored Johnstone for promoting awareness of climate change impacts on Quinault culture and economy. Johnstone's community is the village of Tohola, the capital of the Quinault Nation. The 220,000-acre reservation has a river and 25 miles of coastline. The community relies on everything that surrounds them. Using canoes, they traditionally hunted whales, sea lions, and seals. Nearer to shore, they caught halibut and other fish species, crabs, clams, mussels, barnacles, limpets, sea anemones, and so forth. Johnstone said every bit of that was our food source, and to a degree still is our food source. The third elder is Charles Ka'ai, a Native Hawaiian community leader and activist. He was a principal in multiple lawsuits in defense of Indigenous land rights. More recently, he is working to remove honu, the Hawaiian green sea turtle, from the Endangered Species Act list. Honu is a traditional food for Native Hawaiians. For nearly 2 decades, Ka'ai worked as the Indigenous coordinator for the Western Pacific Regional Fishery Management Council. This federal agency manages the offshore fisheries around Hawaii, American Samoa, Guam, the Northern Mariana Islands, and 7 remote island areas. Today, Ka'ai works on the Honolulu docks for the Hawaii Seafood Council and other organizations. He describes his ocean community as the entire state of Hawaii. His reasoning is that the weather and the ocean affects them all, and they all eat locally caught fish. So in summary, all 3 elders who were interviewed describe their communities in terms of where they fish, hunt, and gather food. All three also associate themselves with both a local community and a larger community due to their shared history of colonization and their relationships with the state and federal government. Whoops, I think I went too far. Each elder was then questioned about climate change in relation to their community. Williams said that climate was good 70 years ago. It was cold, we had snow, we had a decent amount of freeze-ups. Things began to change 20 years ago. The river ice, which used to be 7 feet deep, has deteriorated to 2 feet. Some years there was no snow and no freezing. In the last 20 years, the permafrost has also declined. This has caused massive erosion along the river. The community has had to retreat. They are moving their houses and other structures to a new subdivision away from the river. Besides erosion, climate change has affected the community through ocean and river warming. The community depends on the ocean because the salmon that spawn in the river go back to the Bering Sea to grow for 4 to 7 years and then return up the river to spawn. With the ocean warming, the salmon have decreased in size and are becoming depleted. Adding to the problem is the impact of the non-native commercial trawling industry, which targets pollock and catches salmon as a bycatch. Williams said, all the salmon species, the chum, the chinook, the coho, and the reds, are in trouble. We have not met our subsistence needs now in the last 10 years, and we haven't done any commercial fishing for the last 40 years because of lack of salmon returns in our river. The lack of fish has forced the community to become more dependent on government services. Williams said, so our community has rapidly changed, with the federal government coming in to wipe out our languages, to assimilate us into who we aren't. Johnstone shares similar climate impacts on the Quinault. Like in Akiak, the village of Tahola is being removed to higher ground. Federal funds were secured to clear land and put in streets and sidewalks, but the community members themselves must pay for construction of the houses. For many, this may prove impossible. The construction price is about $500,000 per house, but a lot of the jobs only pay $20 to $25 an hour. Moreover, the Quinault economy is uncertain because it is tied to fishermen who fish the rivers and ocean. Everything might turn out right one year as far as salmon or Dutchess crab or any other thing you make a living off these natural resources, Johnston said. In another year, that might not happen. Quinault are particularly dependent upon sockeye salmon, also known as blueback. Historically, the blueback run could be as high as 1 million fish. But about 20 years ago, the run returned with only 6,500 fish. Issues leading to the decline include homesteading and logging that reduced the forest in the upper Quinault Valley by 99%. The deforestation unraveled the river channel and left the spawners without any place to spawn. Adding to the problem is the disappearing glacier that feeds the river to just a fraction of the size it was a few decades ago. The Quinault responded with a restoration project, which is documented in the video, Can the Blueback Survive? And this documentary will be shown later today during the Ipmen video night. The problem in the upper spawning streams is compounded by problems in the lower river and ocean. Changes in the fall rain delay the entry of salmon into the rivers. when they do get into the rivers, the water is shallow and warm. The warmth takes the oxygen out of the water, and the pre-spawn adults die. About 20 years ago, dead fish, eels, and other species washed up for I think I'm on the wrong slide. Washed up for a mile and a half along the Quinault Beach. Billy Frank Jr., then chair of the Northwest Indian Fisheries Commission, came to see what was happening and coined the phrase dead zone. Trying to see what happened here. Okay. Seems like none of the Quinault elders knew any stories of these kind of occurrences. Eventually, Quinault learned that similar events were occurring off the Oregon coast. 2 universities determined that the cause was hypoxia, which is when the lower water column loses its oxygen due to rising sea surface temperatures and decaying algae blooms. The dead zone experience led Quinault on their journey into ocean science. The number of monitoring buoys off the coast rose from 1 to 6, and the number of instruments on the buoys expanded to look at factors beyond temperature and salinity. Quinault fishermen help researchers deploy and retrieve torpedo-looking self-propelled gliders that monitor the ocean. The Quinault experience is documented in the video Understanding Hypoxia, Dead Zones on the Pacific Coast, which you can see on YouTube. Other climate-induced impacts on the Quinault include ocean acidification, El Nino cycle changes, and the phenomena called warm blobs. Okay, seems like I got one slide out of sequence, but anyways. As far as Hawaii, Ka'ai said the species composition of fishery catches has changed, but the cause lacks evidence. Moreover, he said, climate is changing all the time. You adapt. What's the fear? For Ka'ai, the important issue is community preparedness. He points to the wildfires that devastated the town of Lahaina on the island of Maui, killing more than 100 people in August 2023. If climate change is going to be as disastrous as they said Ka'ai, communities better have enough hospital beds, enough food, and enough water to tide them over. According to various reports, the Lahaina disaster was caused by a combination of colonialism, climate change, and unpreparedness. Lahaina once was a luscious area full of canals and fish ponds. Then in 1893, U.S.-backed businessmen overthrew the royalty. Sugar and pineapple plantations moved in, diverting and privatizing water from 24 streams. When the sugar and pineapple industry closed, the privatized waters were used for tourist resorts and golf courses. The abandoned plantation fields become overrun with non-native grasses that the colonists had introduced to feed cattle. In June 2023, the state suffered an intense drought. This drought is associated with global warming, as hot atmospheric air can retain more water than cooler air. In August, the withered fields and strong winds fueled the wildfire. And adding to the tragedy, the privatized waters are not connected to the county fire hydrants, making them unavailable to fight the fire. In sum, each of the 3 elders indicate that climate impacts are only a fraction of the many changes they are fighting on the front lines for the survival of their communities and their cultures. The last topic discussed, I don't know what's happening, my slides are kind of out of order, but the last topic discussed was traditional knowledge and how it might help with climate change. Williams said the Akiak elders had warned for a half a century that climate change would affect their subsistence resources and community health. The elders spoke about this when the community was doing research as part of its efforts to recreate its traditional form of government. The elders said that it will start warming and affect the salmon and the moose, the caribou, and other land mammals and their migration. Their elders also predicted more extreme storms. Akiak has since revitalized its tribal government and has a government-to-government relationship with the federal government. Okay, and so I'm going to go back because this slide was back here. In 2015, Akiak was one of 33 federally recognized tribes that joined with rural residents to establish the Kuskokwim River Intertribal Fish Commission. The commission's purpose is to engage as co-managers of the river's fisheries resources. In 2016, the commission and the U.S. Fish and Wildlife Service signed a memorandum of understanding to co-manage the river's Chinook stock and to ensure a more self-determined management structure. Traditional knowledge is a key part of the commission's management and research. Okay, now let me go back up. Another project Akiak has been involved in is the University of Colorado's Arctic Rivers Project to research river and ocean temperature. As part of the project, an Indigenous Advisory Council was created, and together with the researchers, they developed guidelines on how the scientists can work with Indigenous communities. Williams, who serves on the council, said information on traditional ways of life and Western science must both be utilized and benefit everyone. If anyone is going to do research, it must be approved by the tribal government. If it will help the community, they'll go ahead and do that research. He added that the elders are going away fast, and before all that knowledge is lost, they need to be taped so that the information is captured and recorded. When asked about traditional knowledge, Johnston reflected on when the Quinault went whaling in canoes in the 1600s, 1700s, and 1800s. The hunters went out 40 miles plus, depending on the migration of the whales, the sea lions, and the seals. The hunters had no compass, they had no GPS, they mastered the currents, tides, winds, and stars. It took that kind of skill and knowledge to get back to where you had left the shore. Johnston said that those who were in the sailing and whaling canoes passed that knowledge from generation to generation. In the same way, he said, community members went seasonally up the river into the Lake Quinault and the headwaters to harvest salmon, fruits, berries, and greens. That knowledge is very much alive, passed from generation to generation, family to family. Like Williams, Johnston said work must be done to capture and use traditional knowledge. Tribes all over the Pacific Northwest have been reaching out to their members to gather their traditional knowledge and legends, mostly through interviews. Work is being done with the University of Washington on agreements to protect their intellectual knowledge. Besides traditional knowledge, Western Washington tribes are building their community's knowledge about their treaty rights, Johnston said. The treaty rights date back to the 1850s when the tribes ceded vast amounts of land to the United States with the agreement that they could continue to hunt, fish, and gather on those lands and waters. In the following decades, non-Indigenous commercial businesses began harvesting salmon. By the early 1960s, the natives were catching only between 2 and 5% of the annual salmon and steelhead catch in Washington. Several of the species were put on the Endangered Species Act list, and the state of Washington ruled that Indigenous tribes could fish only on their reservation lands. What ensued has been dubbed the Fish Wars. During this time, many natives ignored the state ruling only to be arrested. Most notably was Billy Frank Jr., who would be arrested dozens of times. Eventually, in 1974, federal judge George Bolt affirmed Native American treaty rights allowing tribes to co-manage and harvest salmon and steelhead fisheries. But the problem has not completely disappeared. Although the tribe's right to fish had been secured, habitat degradation is such that today 14 salmon and steelhead populations in Washington state are listed under the Endangered Species Act. So while the tribes have the right to half of the allotted catch, when that allotment is zero, they still are unable to continue their subsistence fishing practices. As for traditional knowledge in Hawaii, Ka'ai said there's a lot of knowledge within traditional cultures that can be useful, but only exists in the context of that culture. For example, the traditional Hawaiian lunar calendar is based on a 10-day anahulu rather than a 7-day work week. 10-day ho'onui, which means rising, 10-day poipoi, which means full, and 10-day emi, which means falling. The lunar month begins with the first sighting of the naked eye of the new crescent moon. The calendar recognizes what days to fish, what days to plant, and what days are reserved for the gods. There are ku days, lono days, and others dedicated to the gods, Ka'ai explained. If you are a practitioner of that religion, then those are kapu, forbidden days. You don't do anything. That day is reserved for God, for meditation. It depends on whether you're a practitioner or not. There's no way I can say to you guys, all you guys have to be ku practitioners. For Ka'ai, traditional practices are learned when you are growing up by doing. He questioned whether that information can be transferred and whether transferring that information is important. He said, I don't think it's important for traditional folks. It's only important when you begin to lose it. For 18 years, Ka'ai was the Indigenous coordinator for the Western Pacific Fishery Management Council. He said the work he did there was to preserve the cultural traditions that he thought were important. That was my main purpose, he said, to create this space where people can practice. That's all. And to do that, you have to go through the research process, the proofing, the evidence-based, and all that to establish that regulatory process so that their practices can occur. Ka'ai shared some of the negative experiences he had with researchers who wanted his help. In one case, scientists from California asked how they could come into an island area and engage with the community to get information that they could use. Ka'ai told them about the protocol that was shared by 100 Native Hawaiians practitioners during the Ho'ohanohano Ina Kapuna Puvalu, which means Honor Our Ancestors Conference. Simply put, he said, you need to first bring a gift, bring a story, you need to introduce yourself, they need to know about you. The scientists didn't want to do that. They wanted to helicopter in, get the ideas, helicopter out, write it up, and get credit for it. The researchers did not understand why we don't want to share, I said, because we don't want to. Why should we? Like the Quinault and the Northwest Indian tribes, the Native Hawaiians lost their land to the United States. But instead of a treaty, it was taken by force with the overthrow of the Hawaiian Kingdom in 1893. Ka'ai said, the colonizer comes and says, we're going to make you rich, but you have to give us all the land, and we will guarantee that as long as the land exists, you will live in comfort. It indicates what they wanted, what they're willing to take, and what they're willing to give you. That's the transaction. It's a crappy transaction. So in what way do you want to use traditional knowledge? If it's saving community and saving culture, then yeah. What more do they want from us? They got the land. In summary, there are some recurring themes about knowledge mentioned by the three elders. TK is learned through cultural practices. The rights for those practices to occur are in jeopardy. Protocols exist for sharing TK. TK shared outside the community must benefit the community. elders are dying, and TK may be lost. Finally, from these interviews, I believe that TK is best understood within the context of Native rights and Native history. To me, the responses by the three elders to the questions I posed them about community, climate change, and traditional knowledge are holistic in scope and cover the journeys and the stories they wanted to share. So that's my presentation, and I have 4 minutes to take questions before we go into the other speakers, or comments or questions.
If the culture is almost disappeared or has disappeared, how do we restart or to reserve or to cultivate the culture?
Thank you. I talked to Charlie about that, and because it seems like when you try to do that in partnership with governments and stuff, it can get problematic. So a lot of communities are doing it on their own. They're teaching, their community how to do traditional canoeing, traditional dances. So I think it has to be community driven. Natalie, did you have?
Well, I was only going to ask just ongoing relationships with those communities. Like you had that's a lot of in-depth knowledge that they share with you, and do you have an ongoing relationship with the communities?
Oh, okay. So the reason these three people is because, well, Charles and I worked in the same Western Pacific Regional Fishery Management Council for about 20 years, and Mark here is the program manager for that council, and he's worked even longer. So I knew Charlie and stayed in contact. The other two, I met them first in 2012. We put on with the council and them, and also with the Nature Conservancy, put on a First Stewards Climate Change Conference in Washington, D.C. at the National Museum of the American Indians. And it was like a week-long conference. And then we put on a second one in 2014. So it's Coastal Peoples, address climate change. So, and actually, Kitty, my boss, my former boss, and those guys, they started a First Stewards nonprofit. It's been kind of hard because it's kind of like Ipmen, it's, driven, by volunteer work. But anyway, so I stay in contact. Those guys come to Hawaii now and again, meet up with them. So both of them happened to be in Hawaii in March at different times. And I was just thinking about what was I going to say about this topic? I looked at a lot of the stuff I had done over the years, like I was on the NOAA Marine Resources and Climate Change Task Force, and they looked at community and they did surveys and all that. But I didn't just want to repeat things that are like 10 years old and stuff. So I thought I'd go straight from the beginning to define what is community. And I was thinking everybody, you could ask that too of yourselves and your students. What is your ocean community? How do you define your community? And then how do you define the traditional knowledge in that community and how it passed on? And then also like Charlie, he's, as you can tell, is a little bit of a cynic. He says, climate change, you just get all that information from the outside media. It's more, what do you actually see with your own eyes of climate change occurring in your area? Okay.
I was just going to add that's precisely, I heard the same thing of an elder up north, and they were saying, like, where are the scientists? We're seeing these changes, and they had particular seasonal, things that had happened forever, and they're all changing, but also saying no one was taking particular interest in those observations rather than more general oceanographic ways of looking.
Yeah, and slice of time is what a lot of Western science does. Okay, any other ones? If not, we can move on to the regular session speakers. Okay, and so let me pull up here. Okay. Okay. All right, thank you. So the first speaker we have is Maxine Kutresi, is that you? Kutresi, and she's from the University of Hong Kong.
Hi, everyone. So today I'm going to share the research I'm doing as a PhD student at the University of Hong Kong. It's not about marine education, although I've been an educator for over 5 years. This is mostly proper research in marine science that I think is relevant to coastal cities in particular. So I am focusing my research on cryptobenthic fish. As you can see from the name, they are cryptic, so they are not easy to find as they are very small and they hide on the sediment. They are strictly associated with sediment, so they usually hide in rocks and sand, and they are found in most marine ecosystems. They have a very short lifespan, so they can have up to 7 generations per year. So why we should study them? They actually have critical functions in the marine ecosystem, especially in the food chain, because they constantly provide energy, transforming the energy from their very tiny prey to bigger fish. They constantly provide larvae and food, and it has been suggested that 98% of predation in reefs is done by these tiny fish. Also, they can be very good indicators of environmental change because of their small size and site specificity. However, although they are very important, they're not well studied, especially in urbanized ecosystems. As you can see from the photo from a study in 2022, they usually study them in pristine environments close to reef in very nice locations like marine parks or sanctuaries, but not close to cities, although they do exist there. Also, we have very few information about diet and ecology. So I'm looking at them in Hong Kong. Hong Kong is a highly urbanized city with over 7 million people, but also an incredible diversity with many coastal ecosystems from corals to mangroves and rocky shore, and also an incredible variety of fish species and corals. However, because of the high urbanization, Hong Kong face many challenges from habitat loss, high sedimentation, high nutrients, and fecal coliforms from waste treatment plants. And cryptobenthic fish have not been well studied. They have been recorded a lot in Hong Kong, specifically in the eastern side, but not so much in the west, where I'm going to do my research. And they usually look at them only by diving and not collecting them. So what I'm going to do is I did a literature review on cryptobenthic fish in urbanized cities, because also as the Ocean Decade says, urbanization, coastal cities, like majority of people live along the coast. And oh, there is a monkey there. Okay. Okay, so cute. Okay, so yeah, in the ocean, over 40% of people live close to the city. Urban ecosystems can give very good information and be used as a proxy to understand environmental change. And urbanization changes biodiversity with increase in stress tolerant species. So I want to synthesize existing knowledge, and I already have a few results. There are, when looking at cryptobenthic fish, as I said, majority are focused on coral reef. Only 5% of studies have looked at Asia, and only 2% are related to urbanization. Specifically, when looking at studies on impact and benthic fish, majority of studies have been done in the Mediterranean Sea, close to Italy, France, Spain, and Australia. But if you look at Asia or the rest of the world, there are very few studies. They mostly study the effects of urbanization on freshwater fish. So yeah, urbanization can change, increasing stress-tolerant species and reducing sensitive one, and this can impact the entire food chain, specifically for cryptobenthic fish, because they're so they are very at the base of the food chain. So when looking for my next chapters, I was interested in understanding what factors affect their distribution, if the distribution of these fish changes because of environmental variables or because of prey and predators. So I went to collect them diving. I first selected the sites for my study, choosing sites of high impact, medium impact, and low impact across Hong Kong, specifically the western side that is highly urbanized. And there is a waste treatment plant, there is a big harbor. They also do a lot of land reclamation with the development of the airport. And we went diving, collect the fish, took photos, and then extract the DNA to identify them. And also I contacted taxonomists to help me. Not going too much detail into the methods, but from the DNA, I was able to identify most of them. And you can see that actually the highest number of fish were collected in the high impact sites, which is surprising, and specifically in the wet season. And also, I mostly found 3 species: Tridentiger, Bepigobius, Istigobius, and we can see that Tridentiger, the brown one, is highly abundant in the high impact sites. I also collected more cute cryptobenthic fish. So you can see from this graph, the green area is the low impact, the red and blue, the medium and high impact, and the communities are quite different. The low impact surprisingly has less species diversity and species richness. You can see the graph, the red box plot is the high impact and is significantly higher the species richness compared to the low impact. Same for diversity. The red box plot has a higher diversity compared to the green, which is the low impact sites. And also when looking at environmental variables, we can see that the environmental variables that drive the community are nitrate, ammonia, and chlorophyll. And specifically, you can see the species name, Tridentiger and Megicti, the further away they are in the graph, the less sites in common they share. And you can see that Tridentiger is mostly in sites where like the other one is not, and is also in sites where there is a high concentration of nutrients. So it's highly associated with nutrients coming mostly from wastewater and high urbanization. So it seems a tolerant species. And as in other urbanized ecosystems, few species dominate the community, and this is the case of Hong Kong. And some of species, they actually seem resilient to urbanization, and this is the case of Tridentiger, that it seems to thrive in high nutrients waters, which is interesting. So I'm going to investigate that further in my last chapter. I'm going to also look at, I was interested to understand if the diversity changes and the composition of community changes depending on prey and predators. And because these fish feed on tiny invertebrates in the sediment, I collected the invertebrates and I also collected water to get environmental DNA, which gives you information of what species live in a specific environment without actually collecting the fish. You collect the water, you filter, you get the DNA, and then from that DNA, you know what organisms live there. So I went diving again, collect water samples and sediment, and I filtered the water to get the DNA, and I then seed the sediment into different seed size. I then grinded all the invertebrates together, do like a juice of little animals, and then extracted the DNA from that too. And we metabarcoding, which is a difficult name, but it basically, it's a technique you do in the lab to process your DNA and basically gives you the sequence of DNA of all the organisms that live there. I also did the DNA of the gut content, so I got the intestine from the most common species and then extracted DNA from that to see what do they eat, because I'm interested in knowing what they eat. Especially because Tridentiger in the photo is an invasive species, invasive in California, Australia, and the Baltic Sea. And knowing the diet of invasive species is important to know how they can affect the new environment and what characteristics they have that allow them to colonize new places. This looks quite difficult. It's a graph where it shows the orders of fish I found by looking at the environmental DNA. And mostly, you can see the results are similar. So the majority of cryptobenthic fish are gobies. The purple lines, those are gobies. And you can see they are highly abundant in the high impact and medium impact, which are which are the sites over here. So this is a high impact, medium impact, and low impact, and the gobies are the majority of cryptobenthic fish, and they are higher in the high impact sites. eDNA also allowed me to find species that I could not collect by diving, so it's a very good technique that gives you information about the community, as I found 7 new goby species and blennies. This is another graph showing how low impact and high impact sites are quite different. The whiter the square, the less similar are the sites. So you can see the low impact, the green, are quite different compared to the high impact, the red, which means there are very few species in common, which means that urbanization is affecting the species composition. Species richness, again, was higher in the high impact sites. I also found lots of invertebrates. These are some of them, but I don't have results yet because I'm still processing the DNA results. So overall, I think that this PhD thesis will give insights into how urbanization is affecting overlooked species that usually are not well studied. And I think it will give information how some species respond to environmental change. And by looking how at these sites close to high urbanization, how different the community is compared to the less impacted sites, is interesting for future development and conservation planning, for cities. Okay, so thank you very much. And
Okay, thank you, Maxine. After we hear from 3 more speakers, then we'll call up Q&A. We're going to go to the third speaker while we're looking for the second speaker's PowerPoint. Okay, we get a longer tea break now. Okay, so next we have Ninja Muller, and she's from Witcha University. Where's that at?
Germany.
In Germany. Okay, there you go.
Thank you. Okay, thank you. That was surprising now. I was still preparing my speech. So yeah, I'm Ninja, and I want to talk about exploring concepts to restore society's relationship with the ocean in academic marine education. But before I do that, I'm also back at home a trainer, and I like to get active with people. So I like you to get active, and I want to do a little active life survey with you. So I say something, and if it applies to you, you stand up, okay? We start with an easy one. Who of you loves the ocean? Everybody who loves the ocean stands up. Does anybody dare to remain seated, I wonder? Wonderful, that looks great. Okay, next question. Who of you studied something marine related in university or is currently studying something marine related? Okay, almost everybody remains standing. Perfect. Now, so if you did, then you stay standing, and if you did not, you sit down. Yes. Okay. And who of you encountered traditional ecological knowledge during these studies? If you did, you remain standing. If you did not, you sit down. That's amazing. Okay, you guys who are still standing, we have to talk after this presentation. Okay, everybody, you can sit down. Thank you very much. So, yeah, as you could already read from the title of the presentation, it's about challenge number 10 of the UN Ocean Decade, how to restore society's relationship with the ocean. And I'm looking at academic marine education. Why that? We are all trying to bring the ocean into the curriculum somehow, and I'm looking at where the marine environment is the curriculum. Why do I do that? Well, I think the people that are studying something marine related today are the decision makers of tomorrow concerning marine developments, ocean developments. So I think it is worthwhile to have a look at what they are actually learning, because they are a huge lever in decision making, governmental decisions, probably some laws, initiating projects, and so on. So yeah, it would be interesting to see what they are actually learning about the ocean and which relationship they have, because they will be the ones who will also impact society in their relationship with the ocean. So talking about the human relationship with the ocean in general, I think we are all aware right now overall it's maybe not so great. We have a rather negative exploitative impact on the ocean. There is overfishing, there is ocean acidification, and so on and so forth. I think we all know that. So that is a rather difficult relationship. But also, there is a lot of reason for us to protect the ocean, and there are a lot of great efforts to pursue sustainability to protect the ocean. We are now in the ocean decade, as we know. There are the Sustainable Development Goals, and there is one entirely dedicated to the ocean. So there is quite a lot going on already to protect the ocean for future generations. And I'm going to be bold now to say that I think something is not quite right with some of these sustainability efforts if you want to restore society's relationship with the ocean, because it is still very anthropocentric. So we do have this rather instrumentalizing view on the ocean. We commodify the ocean for human use. And if our sole purpose to protect the ocean is for future human generations, then it's still the same relationship that we have with the ocean. It's still commodifying the ocean. It still instrumentalizes the ocean. Maybe it's more well-meaning, like we are not exploiting it that much anymore, right? We all want to have something from it, but we are not changing our relationship. So I think in order to really get away, free ourselves from this instrumentalizing view we have on the ocean, we need to acknowledge the ocean's inherent value and agency, and we should protect it for its own sake and not for humanity's. I'm not saying it's wrong to protect it for humanity's sake, and we can do sustainable development with it. But if we want to tackle this challenge number 10, I think it needs more than that. So this is obviously where traditional ecological knowledge comes in, I think. It is already now slowly introduced in marine law, governance, and so on, but it's not that much introduced in education. We already heard a lot about it, and especially in academic education. You cannot really find it, or at least some did encounter it, and that's very interesting, so I want to talk with you about that later. But overall, it's not really there. But if we want to have these decision makers of the future to have the holistic view and to take different perspectives, then we should include traditional ecological knowledge in academic marine education, and we should incorporate it because I think it holds incredible potential to actually restore society's relationship with the ocean, to move away from this view of seeing the ocean just as a resource that we are exploiting. And that's why I am looking at how or where traditional ecological knowledge is currently incorporated in academic marine education programs. This is just a little overview. So I created a database with all the different academic marine education programs. That's what this means. AMEP is Academic Marine Education Program. Obviously, it will never be complete. There is always change in bachelor and master programs around the world, but I try to somehow catch as many as possible. And you can see already it's not very balanced around the globe, where you have even access to marine education on a bachelor or master level, where you don't. That would be another whole presentation to talk about access to marine education. Today, it's really about what is written in the curriculum of these programs. And since we are in beautiful Taiwan, I will focus on Asia today. This is still for the whole world. This is just a very short overview what the disciplines are distributed like. So there are only 6 disciplines making up 83% of all the programs offered. And everything else is then in these 13 other, what did I say? 87. I have a blackout, but you know what I mean. You see the pie chart. So and you can also see on the different continents there are different foci which disciplines are focused on. So for example, in Europe you can see there's a lot of engineering and technology, but there is almost nothing in agriculture. And then again in Asia you have almost a third of agriculture. So there is a difference in what different continents are focusing on in their disciplines. Hence, I'm also looking at how the different disciplines incorporate these concepts. In my database, as I said, it's probably not complete, but it tries to be. there's a total of 968 academic marine education programs in Asia, and I could analyze 103 curricula, not because I was lazy to analyze the rest, but because the information provided is very limited in some. I mean, some do provide the whole curriculum, some provide only a few syllabi, some provide a list of module titles, and some provide just the title of the whole program. And obviously, then you cannot really analyze it for any keywords or any concepts that might be in there. Also important to say, just because something is not written somewhere doesn't mean it's not in there, but it gives an indication of the focus of different modules. And I was searching for specific keywords after the methodology of Holst and Brock for concepts of sustainability, traditional ecological knowledge, also of speciesism, but I'm not going to talk about that today because we don't have time for that. And yeah, looking at the traditional ecological knowledge in Asian marine education programs, you can see it doesn't even look that bad, to be honest. But be careful, there are the humanities and the social science, that's only very few, that's only 6 programs in the humanities and only 4 in the social sciences, compared to very large numbers in the applied sciences and natural sciences. And you can see that there is very little in applied and natural sciences, even though traditional ecological knowledge would have a lot to contribute to these. And in humanities and social sciences, it's actually even a bit of a danger or a problem that it can very often happen that you rather teach about traditional ecological knowledge and not with indigenous people. So that's also maybe not exactly where we are aiming to go with this. And you can also see there are some of the keywords that refer to traditional ecological knowledge in a broad sense. And you can also see that actually the only findings that were there were in the traditional and the local keywording. So indigenous and colonization, I know it's a different topic, but you have to be a bit inventive if you're searching for something that is not really present. They are the only words related to traditional ecological knowledge found there. So even if this looks like the left graph, that there is a lot of it, there actually is rather less, because local can also mean local government, local community in a different sense than indigenous people. So yeah, it's not a lot there to be seen. And then in sustainability, just to give a comparison rather, there is a bit more to see. That's why it's also written in the different, like a bit more detailed in the different disciplines. And you can see that agriculture, apart from the visual arts and public policy, that's just 1 each. So that's why it's so high. Agriculture is actually leading the field. But just as a small example, so in sustainability, there is already much more in the curricula than traditional ecological knowledge. So as a conclusion, I already said that it holds a great potential to give different perspectives to people that actively decided to study the ocean. They did decide to get a holistic picture, and it's, I think, almost unfair to withhold multiple perspectives from them. We are multiple people, multiple different cultures on this planet, and it's not okay to only take one usually westernized view on the ocean and say that's the real knowledge that should be taught in universities. So I would be very happy to connect if you know either communities that are interested in sharing the knowledge, getting into contact, and especially if you know universities that would be open enough to try maybe really implementing different views than the ones they have now, because that's what are the next steps in my research. And yes, that's, I think, my time. So thank you very much for your attention, and let's talk afterwards.
Thank you, Ninja. And okay, so Joanna Philippov, take 2, from the University of Hawaii at Manoa.
Aloha makakau. My name is Joanna Philippov, and I'm thrilled to be here. This is my first Ipmen conference, and I have never been to Taiwan either, so it's very exciting. I'm a professor of science education at the University of Hawaii at Manoa. I'm also the regional coordinator of USA Blue Schools and director of the Marine Option Program at my university. My ocean science education projects have spanned ocean literacy-based curriculum and teacher professional development to coastal monitoring programs for students aged like 5 to 18 and their teachers. And then one of my most important roles in this context is as a board member of the National Marine Educators Association and chair of the regional chapter Oceania. So 20 years ago, Ipmen grew out of an NMEA conference that happened in Hawaii, and there's a couple more conferences coming up for NMEA. So there in Louisiana, there's one this July. Next year, it's going to be in Virginia on the eastern US, and then in 2027, NMEA will be back in Hawaii. So consider visiting us. With that, I'm very excited to talk to you about building undergraduate ocean connections, lessons learned from 10 years of a coastal ecology course-based undergraduate research experience in Hawaii, which apparently I tried to get all my information in the title because I have learned no one reads the abstract. So this is everything that I'm covering. I also, when I was reviewing these slides earlier, I realized it's only 9 years. It hasn't been 10. But I thought I couldn't update my slides from when I uploaded them, but it turns out I never uploaded them, maybe, so I could have changed it. Okay, so the undergraduate research experience course I'm going to be talking about is called Our Project in Hawaii's Intertidal, or OPHI. I'll start off with a little bit of background on OPHI, and then I'll outline the structure of the program and share some of the program effectiveness metrics related to ocean literacy. And I'll end by sharing some of the lessons learned over 9 years of this program. So first, to just clear up any potential confusion, the OPHI on the left here are an intertidal limpet. Leilani, I don't know if she's here right now. She has a necklace of an OPHI if you want to know what one looks like. And they're culturally important in Hawaii. The acronym OPHI describes programs that are designed to engage novices in the scientific process and further our understanding of Hawaii's coastal resources and communities. So while a lot of work focuses on the intertidal, the college students that I work with do also investigate nearshore subtidal areas. So undergraduate research experiences where students not only engage in the scientific process, but are socialized into the scientific community are important to fostering students' emerging scientific identities. But they often require intensive support, especially if their projects are to contribute to the scientific knowledge base and not be one-offs. Most labs can only support a limited number of undergraduates due to the mentoring associated with novice investigators. Further, the marine environment exacerbates logistical and environmental constraints. This is unfortunate as place-based, field-based research experiences have been shown to help students connect directly with their local environment and make better informed decisions about environmental practices and sustainable resource use. At the University of Hawaii at Manoa, marine biology is among the most popular undergraduate science majors, as it should be. Look where we're located. And marine biology students are required to engage in undergraduate research experiences to graduate. For ambitious, outgoing, like straight-A students, reaching out and finding a lab or a mentor or a project is challenging enough. But there's plenty of other students who have less than perfect grades, are juggling multiple jobs and have severe time constraints, and are just less knowledgeable and less comfortable reaching out to professors. Further, while field-heavy internships and research experiences can let students who can struggle in traditional courses shine, the university has for years struggled to meet the demand of students for these research opportunities. In short, there's a mismatch between the supply of and demand of undergraduate research experiences. One of the proposed solutions to this dilemma is course-based undergraduate research experiences, or CURES. CURES engage cohorts of students in research projects in a more controlled and collaborative environment than typical undergraduate research experiences. Key features include opportunities for students to make discoveries that are of interest to stakeholders outside the classroom. Work builds off of and has the potential to contribute to a larger body of knowledge. Students engage in a range of scientific practices. Students must troubleshoot, problem solve, and repeat aspects of work for research to progress, and new research questions are generated every year. The OPIHI CURE program was designed to mentor the next generation of community ecologists by engaging them in authentic, place-based research in a challenging and understudied environment. Increase knowledge of the intertidal and shallow subtidal zones by using student data towards scientific products, and leverage and collaborate with research and community groups engaged in the study of and management of Hawaii's coastal ecosystems. Just noticing the top's cut out. So the way that the course accomplishes these goals is through a nested tiered structure that distributes mentorship over a number of collaborators. A key component is the emphasis on group work. Students collect data in groups, they go in the field in groups, and they write and present together. Working in groups with a range of ability and strengths allows students to learn from and support each other. Small groups of students are paired with collaborators. The collaborators provide overarching research questions for the students to explore and assist sometimes with experimental design and training. But ideally, they mostly get to share their passion and have trained student help to answer problems of practice they just don't have the capacity to do. The program shepherds students through the sometimes more mundane tasks of writing proposals and final projects, taking care of logistics like transportation, and please wear sunscreen in the field so you can walk tomorrow, and navigating spreadsheets. Collaborators have included university researchers, government organizations, and nonprofit community groups. This year's projects include snorkel surveys of a newly designed fisheries management area to allow for the track of changes in species over time, and working with a Native Hawaiian education nonprofit to collect baseline data on species abundance in an area of interest. The course structure extends over one academic year and is designed based on constructivist principles, so active collaborative learning, building upon prior knowledge, and scaffolding instruction, making learning relevant, and fostering this development of self-regulation. In the fall, students are introduced to the projects and collaborators as well as field techniques. They write a proposal and engage in service learning. Their introduction to their research site integrates an understanding of and connection to place and ethical research. For example, they learn protocols for entering a space like OLI, and they research the history, place-based names, and mo'olelo, or stories of their site. In the spring, students conduct fieldwork and analyses, engage in outreach, and iteratively write a scientific paper. In addition to presenting their research, they work on a partner project that is co-designed with the community collaborators and is more practical to the collaborator than a paper or presentation. So that might be something like a field guide. In addition, OPIHI elevates the hidden curriculum of research. So these are social and professional norms that are second nature to many of us, but opaque to others, especially those from underrepresented groups. So these aren't formally taught or explained, so they can be completely bewildering. So these include things like dress codes, like what does one wear to a field day, and what do I bring to a day in the field? They also include things like, what do I do next after this class if I want to continue to do research and go on to pursue graduate school, or what do I do next if I don't want to go into research? Like, what are some other options? To elevate a Hawaiian place of learning, we model the creation and nurturing of kuina, or connection, when working with community using Hawaii Sea Grant's Ku'ulana no I'i as a guide, which is excellent. It's very digestible set of guidelines that aim to build more equitable and reciprocal community researcher partnerships. For example, in addition to working to answer questions posed by the community and be reflective of community needs, students write positionality statements to situate themselves and reflect on their role. And finally, we make students malama aina. They give back to the places and community in which they conduct research in order to develop a responsibility to place. So I don't have a lot of time to go into all the details of the metrics and the p-values. So this is a high-level overview of our findings, but I'm happy to discuss them more. But we used pre and post surveys, rubrics on assignments, and interviews by an external consultant. Students significantly increased their content and scientific process skills, from formulating a research question to writing scientifically. They gained in their confidence and their ability to convey scientific information and share that information to both scientists and to the public. They also reported identifying more like a scientist over the course of the program and reported they were more likely to go into scientific research. And perhaps most importantly, they overwhelmingly developed a deeper and stronger connection to place and Hawaii's coastal environment. In summary, this cure allowed for the scaling of both scientific research and undergraduate engagement in marine research experiences. The nested configuration of this program can serve as a model for addressing a critical gap in opportunities for students to fulfill research credits required by many natural science departments to graduate in any environment. And over the years, we've made many iterative improvements to the course, including the addition of partner projects, group contracts, and new this year ungrading that focuses on improvement and feedback versus grades and points. There's definitely challenges though. Ideally, there's a perfect synergy of scientific and educational goals and needs that are met, but the reality is it's really, really difficult to balance these two goals of the program. The research questions and ideas that come from our partners can be really hard to fit in the academic year, the entire scientific process, even if they're modified. And it's challenging to come up with cost-effective, authentic research projects that fit with the collaborator goals and allow students to engage in a variety of scientific practices. It's also really hard to get students with varying abilities to analyze and interpret complex data in a short period of time. So the rigor of the research projects has varied. We keep getting better, but sometimes we're leaning more towards the educational or the scientific goals of the project, which can be frustrating, but the reality is for just one professor and one TA to take 16 to 18 students to the program, like we have to let go of those like minutia a little bit. And it's also a first foray into scientific research. It's not going to be perfect. The class is for those new to research. If they decide they like research, great. We can shepherd them on to additional goals. And if they decide they don't like research or field work, that's also great. Let's find a different field for you. With that.
All right, thank you, Joanna. Okay, next we're going to have another speaker or presenter from Hawaii. Her name is Kanisa.
No, that's
Not
sorry.
yet?
No.
Oh, okay. Kanisa Serafin, and she's going to be presenting. We're going to do a pre-recorded video, but she's also following us on live stream, and she'll be available through the Zoom for the Q&A session, like Nate was. And before I forget, she did send over to me some stickers for Voice of the Sea, which she will talk about. So I'm going to put them up here. So if you guys want a sticker, help yourself. Okay. Aloha.
Aloha, thank you everyone for being here today. Thank you to Sylvia for hosting this session. I'm Kanisa Duncan Serafin, and I'm presenting today on behalf of myself and my co-producer Thor. We're from the University of Hawaii Sea Grant, and I'm going to share about our TV and online series Voice of the Sea as a model for sharing stories across the ocean. The mission of our series is to advance ocean literacy and environmental literacy through stories of science and culture in the classroom, in the science center, and in the community. We air on TV, on broadcast TV, on Saturdays and Sundays at 6 p.m. in Hawaii. We're on TV in other parts of the Pacific as well. In addition, we have online portals like Vimeo and YouTube, online premieres and watch parties. We've also done live screenings and audience surveys at events, at science centers, at art festivals. Each of our episodes gets a dedicated webpage that has the 30-second trailer as well as access to the episode in its full version, where it'll be subtitled in English and Samoan. Sometimes it's also subtitled in Spanish or Hawaiian or even Japanese, depending on the episode itself and kind of what the community connections were. On the web pages, we have curriculum connections. So our curriculum is aligned to the ocean literacy principles as well as the United States Next Generation Science Standards. And then we'll have additional resources. So it's a curated list of credible sources and activities that align with the episode. The goals of our series are kind of have four main parts: to expose viewers to local science, technology, education, and mathematic research and cultural connections, to increase viewers' interest in and knowledge of the mutual influence between humans, land, and the sea, and then to develop awareness and interest in STEM and cultural careers, to provide a venue for researchers to share their findings. So there is a solid body of research demonstrating that matching audience demographics with relevant role models like gender, age, ethnicity, background, etc. really helps the viewers form connections and promote career interest among youth. And there's also been valuable research pointing to the ability of video and television to do this, especially in cases where the audience can't meet the experts in person. We've been able to demonstrate the effectiveness of Voice of the Sea in teaching concepts, promoting interest, and developing connections, emotional connections to the voices, the experts on screen. We're in our 12th season this year in 2025, and we produced over 130 unique TV episodes, engaged over 600 experts, and we're working on growing our co-production model so that each episode is produced really in collaboration with the experts that are featured in it. We've won also 49 Telly Awards and been selected to show episodes at various cinema events, which is really fun. I'm going to play you a trailer now for our episode Limu Love, which was in season 9, episode 7, and this episode won a bronze Telly Award. We got to take a trip to Hana on the island of Maui and learn about the unique algae or limu that they have growing there and why it's important to the environment as well as culturally in Hawaii. On the next Voice of the Sea,
limu is important to Hawaiians and Hawaiian culture.
This ike Hawaii that has been passed on by our kupuna, you need to take care of that ike and pass it down.
We started the Limu Festival as a way to create that awareness and to celebrate Limu.
There's so much excitement and interest. More people are telling Limu stories around their tables.
Limu is that connector from Mauka to Makai.
Voice of the Sea, online at voiceofthesea.org. We know from audience surveys at a variety of venues, from outreach events and designated Voice of the Sea screenings, as well as with classrooms with teachers and students, that our episodes are effective at increasing awareness, content knowledge, interest, as well as understanding across groups. We studied a range of topics from aquaponics to wind turbines, deep sea research, Hawaiian fish ponds, aquaculture type work, beach health, as well as a 4-part series on freshwater recharge, reuse, and conservation. In focus groups, our viewers showed a clear preference for in-depth content. They want long form and fewer experts per episode, and that's actually influenced the way that we make our episodes. One of the things I'm really proud about is that we're able to make episodes about high-level scientific content, mercury, clean rooms, earthquakes, contaminants in the water. This is a trailer from our episode about the Hadal Profiler, which carries a whole suite of scientific instruments and is heading to the deepest ocean trenches. On the next Voice of the Sea, we're going to the deepest parts of the ocean with the Hadal Profiler, a new science tool being developed by University of Hawaii researchers. We check out the profiler and some of its instruments, head to the lab to see organisms discovered in the deep ocean trenches, and meet some of the researchers, engineers, and students who are part of the team developing the Hadel Profiler. Voice of the Sea, online at voiceofthesea.org. So we have these episodes and we know they're effective at engaging people and teaching people, but that's only good as long as people are viewing them. So when we set out to make Voice of the Sea, our goal was to get on television. I really wanted to access this group of the public that doesn't normally attend science outreach events. TV is still a really important thing in the United States and globally. There are about 125 million TV homes in the US last year. TV right now accounts for about 35% of the media consumed in the United States. We're reaching middle-aged viewers. There are about twice as many as youthful viewers watching television, and these trends are expected to increase through 2027. Over here on the right-hand side, you can just see a breakdown in demographics, and definitely TV time is less for young adults. TV is also a really critical component of marine science education with respect to our lower income and rural communities, especially. 1/4 of our population lacks high-speed internet, although 91% of us are online or have some kind of internet access. Almost 50% of the world lacks high-speed internet access. Being on TV is really important in places like American Samoa, where we're able to share information directly with the community. And we're also able to share information online. This episode, Sea Level Rise in American Samoa, came out in December 2024, and within a week we had 10,000 viewers online. On the next Voice of the Sea.
If the harbor isn't open, it's really hard to get supplies to the people of American Samoa.
The sea level around our runways is rising.
Not only is the sea level rising, but also the land is sinking.
Even minor storms have caused really significant land loss.
From a purely trend and sea level rise perspective, it's the most vulnerable Pacific island.
You know, it's scary.
If we want land for our future generations to live on, that's something we have to fight for today.
Voice of the Sea at voiceofthesea.org. We're on TV, but we're also online on social media and on email. So we're taking a multi-pronged approach. That Hawaii TV audience is still our primary focus. We had about 24,000 viewers per week for a number of years. We're starting to see that decline. Our YouTube channel does have 6,000 subscribers, and some of our episodes have a lot of views, up to 300,000 or so. All of our projects, each of our episodes, we really try to collaborate with the people who are in the episode as much as possible. It makes a way better episode, and it also helps people to gain ownership of their episode and Voice of the Sea, and then they share our other episodes, and so it's kind of like this wonderful snowball momentum effect, if you will. This particular project was about SMILE. It's the Summer Marine Mammal Intensive Learning Experience at the University of Hawaii's Hawaii Institute of Marine Biology, and we worked with the SMILE program to film and produce and also to premiere the episode in a live screening where the students came who were part of the program, and it was a really fun experience. I'll play that trailer for you now. On the next Voice of the Sea.
SMILE stands for the Summer Marine Mammal Intensive Learning Experience.
We spend 10 days teaching all things marine mammals.
There are 6 call types that Hawaiian monk seals make.
This is a false killer whale tag deployment.
No 2 dolphins have the same dorsal fin. It's kind of like a fingerprint.
We've now measured close to 40% of all the whales in Hawaii.
We felt it was really important to teach about our place names.
Having this program was amazing.
Voice of the Sea, online at voiceofthesea.org. And lastly, our findings and recommendations. So coming out of our surveys, small and local is effective. Share your stories on TV, online, and in person. Less is more. So again, from our focus groups, we can fit about 5 to 8 people or voices per half-hour episode. For us in making Voice of the Sea, the audio is really important. It's how we edit the stories. So my number one recommendation is use a microphone. If you can. My second recommendation is to film with 2 cameras, and that really facilitates the editing process. So images on top of it. have 2 cameras, you can edit out people's ums and ahs and also cut between parts of the conversation. Phones actually work great for filming. We use them a lot. I recommend turning them landscape and in the highest resolution possible, and use a tripod. We've done a lot of our Zoom or computer interviews, and in that case, we also ask the person to hold their camera to the side on a tripod, prop it on a coffee cup or something, and then you have a 2-camera interview that you can edit. So you have one from Zoom and one from the camera. And lastly, collaborate with your community, because then people will be interested in the things that you're sharing, and you'll know about the resources. They'll want your resources. They are your audience. They can provide media. So a lot of times we're making an episode and we're taking the photos and videos people have been collecting for years and putting them into 1 half-hour episode. And it really helps to make that their life's work, their story so much richer in our episode. That's all I have for you. Mahalo. Thank you for watching my presentation. I wish that I was there in person with you. Please reach out to me if you have any questions or you'd like to collaborate. My email is kanisa@hawaii.edu. You can watch episodes of Voice of the Sea online at voiceofthesea.org, and we're on social media at Voice of the Sea TV. Mahalo.
I have a question for my team regarding to the DNA. Did you say that you found
So I mentioned like never recorded, but just compared to the collection. So with when we went to collect the actual fish, we found a lot of species, and then with the environmental DNA, we found other species that we did not collect, but were also recorded. Although I didn't identify all of them yet, so there are a few specimens that we could not identify. I know there are gobies, but I don't know what species, so there might be new ones. Like never recorded in OnCall before, but yeah, I still need to contact new consultants.
Did you take the samples from like next to the other gobies' height?
You mean for the water?
Yeah.
Yes. So we were diving and we had this bag that I actually got from Decathlon that you can fill up with like 6 liters of water. So we went diving and close to the sediment where these fish are, we collected the water. Yeah, it's quite challenging, but you manage to fill up the bag and then you can close it. You bring the bag to the boat and then you filter it in the lab.
Thank you. Also a question for Ambassador about your research, because in the last part you mentioned you sample the water and get environmental DNA to sequence to see what's inside, and you also got something like you probably didn't know before, and also analysis the gut content from the benthic fish, right? Did you compare the data for these two, and how are you further going to use this data? Are you going to do like this data? Are you going to do like long-term monitoring or something? Are you going to do like long-term monitoring or something? Or to the pollution and to see how the environment change will change the distribution of the benthic fish? Thank you.
Yeah, thank you for the question. So I did not analyze the data yet. For now, I only know from the lab work that I did that the low impact sites did not have crustaceans in the diet, and the other fish do. So I can already tell the diet is different. And for the future, I will compare the invertebrates I collected with the gut content, and then we'll see if among those invertebrates there are tolerant species. Like we know that some invertebrates like worms are tolerant to pollution, so that's a sign that the sediment is polluted. So long term, it depends on what I find, the results, but I will definitely think about future research to maybe use those invertebrates as indicators. Because at the moment, usually only some animals are used as indicators for pollution, but maybe with the results of this research, even the fish could be used as an indicator, like the Perentigay and some of the invertebrates that I find. Yeah.
Basically, you use the characteristics of those they're resilient to the environment change to assess the impact.
Yes, because you have a literature where some species are tolerant and some are sensitive. So I will use that too as an indicator of environmental pollution. Yeah.
Okay, thank you.
Okay, and Kanisa is now on too, so if you have questions.
Hello. My question for Joanna. Joanna, sorry. Yeah.
This is Joanna, and this is Ninja.
We look the same.
So, Ninja. Okay, thank you, Ninja presentation. And my question is, 就是在 PPT 里面，就是有就最后也有放一张，就是那个像是水管的那个材质，然后这材质是什么？然后是否是可以用再生材质，像是那个死掉的珊瑚的碳酸钙的材质，或者说牡蛎的材质，是哪一个材质的
？Yes.
Next, the final picture in your presentation, like a pipe, and what? Like a pipe, or what kind of material you use? Can you use reproduce material to make it, or do you?
I don't know which pipe. There was text. Or do you maybe really mean hers? Do you have a pipe in the back?
Maybe keeping the quadra. Oh. Yeah. It's a.
Yeah, but
the PVC pipes were in a square, and the square, you can use it for different ecological sampling methodologies. So you can use it for like species abundance if you want to see how abundant certain species are in an area, and that is just the one that I showed is just the one that we use for the intertidal. Quadrat, yeah.
Back to yourself.
I have the students make them.
I have a question for Ninja and maybe for Kanisa also. And maybe it's more of a rhetorical question, but I'm interested in just hearing both your thoughts. You're suggesting that embedding TEK in academic programs around marine science and marine education would help to restore humanity's relationship with the ocean, and it's not happening. Like you're not finding a lot of TEK in programs. And so, how do we fix that? Like what are steps that can be taken at scale in academic programs around the world to embed more traditional knowledge into undergraduate and graduate studies?
That's a difficult question. And I was supposed to say that's a great question. I think it is a bit case by case. I think it will be difficult to scale up one way how to do it because every community is different. I know that there are, for example, in Canada or in New Zealand, that they are much further in incorporating traditional ecological knowledge in education and also in academic education. So I would firstly see how they are doing it there. And that's why I was also asking, because I don't have the answer right now. I would like to really collect different practices, how you can engage the communities, the local communities into the education. But I don't think there is a general answer because, yeah, it's different everywhere around the globe. But maybe you can already, by comparing different programs where it actually worked, maybe you can define some best practices and then you can make it easier for other universities or other communities, depending who starts the process. But I think it should come from the universities actually to make that step. Maybe that would make it easier, but I don't have a final answer to that question yet. And I don't know about Kanisa. Could you hear the question?
Yeah, can you guys hear me?
Yes.
Yeah, can you guys hear me? Oh, aloha. Aloha. Oh, this is fun. I can't see you anymore. I had it's great to be able to have my voice in have my voice in. Thanks for the question. I think that was Craig. I have two thoughts. One is that we just did an episode that is coming out about oral histories, and I was putting together our content page. I was really amazed to find a real range of oral history curriculum across geographies and kind of genres, and I thought that that was a way to cut across grade bands. And also in the episode, the woman has a really nice quote about oral history being a way to connect people who live in Hawaii but are not from Hawaii, and how to connect those traditional ideas by gathering oral histories. And that's something that can be done, you know, really at scale, and also small or big. And then I think the other thing is that since I've lived in Hawaii, and I think Joanna can attest to this, also being at the University of Hawaii at Manoa, that there's been a really significant change in terms of researchers and education and partnering with community. I think Joanna can share the program Kulana Nua'i that she participated in really does an excellent job. And we're certainly not all the way there, but I think that that's caused some really positive change.
Okay. All right. So, hello everyone. I'm kind of nervous actually. So I have a question for Maxine first. So about the species that you found out of all the cryptobenthic fishes of species of cryptobenthic species that you found out. I'm just curious, are all of them belong to the same family, genus, or even the same ordo? And do they have the same like features, like how they digest food and all of the stuff? Do they work in the same way? And also, I have a question also for Ninja, which is you said to us that like there are around please correct me if I'm wrong. There are like around 900-ish of curriculums that use TEK, but you only use like 100-ish for your sample because the rest will be only like there are only like what's it called modules only, basically not like a whole curriculum kind of thing, so you cannot use that as your sample. My question is, why do you think that happened? Of all the 900-ish, there's only 100-ish that you can use as your project. Thank you.
Thank you for your question. So the cryptobenthic fish, they include many different families. So that different orders and, different families that belong to the cryptobenthic fish. The ones I collected, they mostly gobies, so they're mostly the same genus, but different species and also different genus. So the genera like Dragantige is a genus, Bephigobius is another genus, but I only found one family, especially in the urbanized sites. Yes.
And to your other question, so there were these 900-ish programs around Asia, and how I collect my data is basically I visit the website and I take all the information I can get from there. And sometimes they do provide a whole PDF that you can download with all the information, but sometimes they really only provide the title of the whole program. So, for example, sustainable fisheries, and that's it. And it doesn't make sense to search for keywords because there are 2 words that I could look at, and then I cannot compare it to other things. So I'm already trying, because there is so little, I'm really trying if there is, for example, a description on the website, even if it doesn't say the exact modules, but at least the description of the whole program, I also take that. And I didn't do that now here, but I also differentiate between, do they have it in the title of the whole program? Do they have it in the description of the program? In a course title or in a course description. So there are different levels I also look at. I just didn't put it in here for time reasons. But yeah, that's why I could take only 103, because there was really no way to use data from the others because there were just a few words provided.
It's amazing how a student can find a university they want to go to. They can't even
It's interesting, yeah. But I gotta say, Asia also operates very different than Europe, and I'm obviously acquainted with the European system. So there might also be some European bias, right? Because, yeah, so a lot to take into account.
All right, so let's give a hand for these speakers. It's and Kanisa, thank you. And it's tea time, and we'll be back here at 4 o'clock.
Yes, quick announcement. Yes. Yeah, 30 seconds, so don't occupy your time. And first one, we have the attendance certificate. So, 出席证明, if you are not, go to the registration desk and to get your participant certificate of participant. And second, if you are for registration, still not get the t-shirts, and please also go to the you are invited speaker or you are for registration or you pay for buying the t-shirt, and please go to the registration desk to get your t-shirt. And I think some of you get a badge, and that's I'm sorry, that's a typo. Yeah, the badge, there's a typo. But you and I know about the history. We know the history. So when you get it on and someone say, oh, it's a typo. Yeah, that is our history. Sorry, it's not good, but at least I know, and this is our history. We met in 2025. And here is a Takao Declaration. Please, everyone, I hope everyone can sign Chinese and English, and tomorrow we will have a declaration. So please sign it, and I hope you will be one of the history. And please, all the invited speaker and Peter, come with me. Yeah, to look for Ishan. That's it. Thank you.
Okay, see you back at 4. Okay, all right, we're going to start next with the next speaker, and I kind of misplaced my phone, so let me see. Is it listed somewhere, or somebody can somebody look and tell me the next speaker is? Okay, thank you. So Young Hui Chin.
Yes.
Oh, that's you. Okay, thank you. Excuse me, I got just engrossed. David. Okay. David. I got engrossed in the conversation and I lost track of time. So David, would you like to come in and give your presentation?
Okay, thank you.
Thank you.
Good afternoon, everyone. I'm very appreciate you stay so late. If you exhausted the day, usually it is most challenging at the last 2 presenters. I'm going to speak very quickly on my 20 years experience on promoting education science or education, marine education. That's my insight, my experience, because I'm going to retire in this summer. So what I say doesn't matter or hurt anybody. If it did, just bear with me. That's the privilege of the retirement, right? Okay, I work in the National Museum of Marine Biology and Aquarium. Actually, I'm a fish guy. I'm not an education person. But when I was trying to educate department, I was asked to start to conduct many different kind of education programs, including exhibition. So the third building we call the Water World. Hello. I'm one of the curators in coordination the digital display in Taiwan the first time. This is the building. But I don't, if you are interested in to visit our museum, maybe later after that, it won't take 2 hours drive, but that's the place I did. I opened it, my suggestion 10 years ago, I opened it as a park. We don't treat us as aquarium or museum only. We open every source, do all kind of education program as possible as we can. So this is the really size of our museum. I'm going to start with this. In the first beginning, I start to carry all kind of education program. As you can imagine, a student research project, teacher workshop, and summer camp, and digital thing. If free student go to the field, there's an intern student come with you to learn how to carry out education program, all kinds of stuff. But one day, as we build a staff, and found, oh my God, there's a lot of trash in the ocean, and it's not only small part of it. It's a great part, and then start to dig the data, and I found, oh my God, 2006, international group has formed to study such big issue, but in Taiwan, nobody care about it. People only start to do the beach cleanup. Then now it become a fashion. Even some group or association use it, make their own profit. Or industry doing something, I'll do something for the society, so let's go clean the beach. But one of my partners told me, the more they did, the more trash they get. And it so shocked me again. Oh, are we really know what is going on? And one of the values shocked me. 80% of the trash coming from the land. And it's very interesting. In the biological system, in the biological world, there's no trash at all. You cannot find a trash in the wildlife in Africa. Even the boo-boo was recycled again. There's no trash at all. Trash only produced by humans. And so, oh, no. But I did ocean education. What's the relationship with the land life? No. But this tell me one more thing. No. You cannot think in that way. Because this is the real thing. And it will happen. And it happened more frequently in the recent years. When you get a shock. Oh, that's not impossible. But it's true. It's really happening. So everybody go to the beach. The more you did, the more trash you get. Oh, you get a lot of trash, clean up. Oh, I'm great. And 3 days later, you come back. Oh, the trash is much more than I thought. So we know do something good for the nature. We are willing to do. But do we do good enough? We have to think a little about. Because we have limited budget. Everybody talk about money. But we have a limited budget. We have a limited power source. We have limited energy. So this brings me one question. Our limited budget, power source should do on what point to make it get a better effect or great effect than we thought. And this effect can prolong in lasting forever or continuously to meet, we say, sustainable. What is sustainable mean? Sustainable. Everybody say, oh, we're going to SDG 10, we're going to SDG 70. But what is the, if we ask what can we do in daily life for sustainable development? That's my question. So when we did this, we find the trash keep coming back. And it's like a never-ending job. You never see the end. But you wish someday, when you go to the beach again, there's no trash at all. But thing is impossible. It's not possible. The situation is more serious and serious than we thought. So I rethink. My advisor in USA instead told me, David, have to see the big picture before you do any research. Otherwise, you don't know what you are doing. And so, big picture is so large. Picture? No, you see, He just tell me you have to think systematic. What is systematic view? You know what is affect you, and what you did will affect what in the next. So when I put it on this field, 80% the trash coming from the land, but we see the beach clean up. We see a lot of trash in the ocean. When you put it on a systematic view, you will find they were connected each other, but we did not care about it. Then one time I enter a lecture. The speaker said, maybe the system is too big. So I said, I think it's too big for me to do something. Government will do that. Somebody stronger than me will do that. Then we don't do anything because it's beyond my power. But this is not really right. No. So I start to think about ideas called big picture. So let me go back to the climate change. Everybody worry about climate change. They will affect what. You can mention it. But do we really understand what the water cycle did with us? What is going on there? Is this the idea we learned from elementary school? But when we put on our education program, did our education program really fit something, not just get the knowledge, but really bring some action to deal with climate change or the big picture, what I mentioned later. And one day on the street, I found this picture. It's it's so simple. But what really happened is not just what you see is so. It's happened. There's many things happen on the land, on the forest, on the river. But here, you did not see its impact on the ocean. No. So it's part of view. 3 minutes. Okay. I try to. So in Taiwan, landslide is constantly happen. As long as a big storm or a typhoon, then we will get the landslide. But when you landslide, go to the coast, you will find something like this, very floating wood, packing inside the harbor. No fishboat can go out the harbor because there's a lot of the floating. There's a lot of floating wood in the harbor. So this giving you another example, and I also found, this is coastal animal. Animal will die due to the landslide. So I go to read a lot of things and found, Satoyama, great. This is a cost to ask people to deal with the harmony relationship with the mountain. Then later you say, yes, Satoyama. This is great too. Then mountain they live harmony with the sea. But as a matter of fact, we have to combine them. This is the story I read. A farmer noticed one thing. The culture oyster is affected by the river discharge because the nutrient is mainly from the river discharge. And they said, no. So we have to think about both land and the ocean. So the picture becomes bigger and bigger. You will find, it's close. You will find, yes, land is starting to have a good close connection with the ocean. Then you will find one thing. This is the idea we know. If you call something is throw a stone into the water, they will cause the river. We call the butterfly effect, right? Everybody knows that. But if we do apply this idea, apply what I said, you will find one thing. All things can become in one big picture, one ocean, the core of our ocean literature, and the global warming literature. And you will find the system interacts with each other, but we barely know the relationship between them. So this is my suggestion. I think we should put mountain, forest, river, and ocean together. You have to see the big picture. And I have the small demonstration here. I make a card. Worry, I forgot to get in. This is I call La La card in Taiwan, in Chinese. And when you go this very beautiful card, when you start to pour down to destroy the mountain and the river, and you will get a lot of floating wood. Similarly, this is a very beautiful city and a beautiful ocean. When you start to destroy the system, then you will get the dirty ocean. But you can push it back. I will get one piece, sorry, but time is up, and maybe when show up in later in Q&A. And this is my sharing. Thank you.
Thank you, David, for the inspirational presentation. Thank you. Okay, and next we have Mark Mitsuyatsu. He's from the Honolulu-based Western Pacific Fishery Management Council. I worked with him for decades, so know him well.
All right, thank you very much, Sylvia. Yeah, my name is Mark Mitsuyatsu. I work with the Western Pacific Fishery Management Council. I'm the program officer there. I deal with regulations and the regulatory programs for fisheries. I let Sylvia and Kitty handle all the education and outreach stuff, so I'm a little bit out of my league in terms of the education side. But what I wanted to do is share some information about what the council is doing with regard to integrating traditional biological information or empirical knowledge or fisherman observation, whatever you want to call it. How do you actually get it into science and then get it into management for decision making? And that's what we've been trying to do. I've been working with Charlie for 20 years, who Sylvia talked about, and we've been working with different communities throughout the Pacific Islands. And so I'll give you an update of some of the things that we have been working on. Let's see. Is this it? Okay, I felt like you guys had this presentation once or twice already because Sylvia talked a little bit about it. Nate also talked about it from American Samoa. He works with us too. But in any case, so the councils was created in 1976 by Congress. So we are what they call an instrumentality of the federal government. We're not a federal office. Yeah. They created 8 of us, and they call us regional councils. And you can see how we're kind of split up. There's one in Alaska too that I cut off. They're really big. And then our jurisdiction is the Pacific Islands out here, which Sylvia had showed a map earlier. Includes the state of Hawaii, includes the territories of American Samoa and Guam. Right? American Samoa, south of the equator. Guam over there, and the south end of the Mariana Islands, and the Commonwealth of the Northern Mariana Islands. Yeah. So we're not only spread out geographically across the Pacific, north and south, but we also have different political standings. And Nate talked about that, how they don't have a vote in Congress. The voices are all different. And actually, like in American Samoa, they're actually nationals, they're not citizens. Yeah. So there's all these different things that we need to navigate through. And I'm glad you guys asked the question about, his standing, the American Samoa standing with the U.S. government, because the Hawaiians have a different standing. And when you go to all of these other islands, they have different relationships. So anyway, I'm distracted. Okay, so how do we manage fisheries? That is what we're supposed to do. So Congress created us, the regional councils. One of the unique things about the Magnuson-Stevenson Act, which gives us our authority, it created the councils, is it requires us to balance sustainability. The resource has to be healthy. But we must also provide opportunities for people to use those resources. So unlike a lot of other authorities that are out there that's on a conservation kind of mode, we have this extra requirement that we need to make sure people can use the resource too if it's healthy. Yeah. And so the way that we do that is through these fishery ecosystem plans. The process that we use to come up with all of these plans is a public process. Everybody can participate in all decision making. And so we have plans, archipelagic-based fishery ecosystem plans for the archipelago of Hawaii, American Samoa, the Mariana Islands, and then this one here is for pelagic species, because pelagics are found throughout our jurisdiction. They don't know boundaries, they don't stay in fences and things like that. So that includes tunas, billfish, marlins, mahi-mahi, wahoo, all that kind of stuff. They live in this plan. And so these plans are living plans. They are dynamic. They're adaptive. We amend them all the time. Is there anything else I wanted to mention about this? Okay. So I'm going to get to the meat of what we're supposed to be talking about here. And, I did miss something based on our plans. The Magnuson Act requires us, because this is going to come into play later, it requires us to use the best scientific information available in making decisions. So lack of information is not going to prevent the council from making a decision, but we're required to use the best available. Okay, that comes into play. The other thing that we're required to do is all those species that I mentioned that are in the plans, we have to establish annual catch limits. That means all of them are quota-based managed fisheries from the start. Okay, and that plays big too into how do we incorporate traditional ecological knowledge, right? So, looking at this slide here, I mentioned annual catch limits. For every species in all of our plans, we need that. I mentioned best scientific information available, right? That's going to go into these stock assessments. That's going to determine how much fish there are in the water, which is going to determine how we get to our annual catch limits. And we don't do this. That's not our job. We rely on the federal government, the National Marine Fisheries Service, the Science Center. They have all the experts. They got all the information. They're the ones who need to come up and tell us how much fish there are. So what do they use? A lot of fishery-dependent data. They look at the fishing industry, the community, non-commercial, recreational, commercial fisheries. They're looking at who's participating, how many are participating, what kind of gears are you using, how much fish are you catching, how much effort you're putting in to catch that fish. Yeah, these are just some of the basic things. Then they also bring into the stock assessments life history. So for each of the species now you got to bring in life history. How fast does that fish grow? What age does it mature? When does it reproduce? How long does it live? Where does it live? All these things goes into these stock assessments that the scientists are trying to produce and give to us so we can make these management decisions. That's the law. We're required to do that for all of them. Okay, so one of the things that we've been trying to work on, and the stock assessment people are trying to do this, is they're trying to bring in environmental information into that model. What does that include? Basic things like wind, currents, right? Why wind? What does that matter? Tell you what, our boats in our fisheries are all small boats, trailer boats. If the wind comes up, you're not going fishing. What are they looking at? They're looking at effort. So that wind directly affects effort, and the stock assessment. Currents, change direction, change strength, affects fisheries. Habitat, changes in habitat affects all of this. All of this stuff gets put into these assessments. And we have to base our decisions on this. And so now with these stock assessments come out, one of the other things that's required is it has to go through peer reviews, right? Like any scientific paper, you got to go through a peer review. So we put it through a peer review, and guess what? That's a public process too. Okay. The other thing we're required to do, which I think I'm on the wrong page. Am I on the wrong page? Yeah. Where's this? This one? Okay, here we go. The other thing we're required to do is for each of our FEPs, fishery ecosystem plans, we have a plan monitoring team. Those guys are made up of local fishery and federal fishery managers and scientists. They review the data and information every year and generate a report. This report comes back to the council as a performance report on the fishery, and they're the ones who need to put up the flag and say, hey, there's a problem here. You guys might need to take an action and look at this. Do a study on that, whatever. Yeah. That report not only goes to the council, that report is required by the National Fisheries Service to go to Congress. So that's an official document that we produce every year, okay, on the performance of our fisheries. And so it's another public process. One of the things that came up a number of years ago is when the fishing community participates in these processes, they start raising their hand. Wait a minute, you guys did this stock assessment, you guys said here's the catch rates, and the catch rates did this, and the catch rates did that. Well, what about this, and what about that? And all of those points are good, and the scientists acknowledge those points, right? And so eventually the fishermen started to get frustrated, and so they started holding their own meeting, annual meeting. And when I talk about a fisherman from our region, we're talking about indigenous fishermen, commercial fishermen, recreational fishermen. They're all kind of together. A lot of them are all the same people, you know? And these are people with generational knowledge. And so they get together, they started making some changes, and they started documenting notable changes. Because these are the type of environmental perturbations and things that the science groups were not recording in the data. And so for the last 5 years now, fishermen have been doing that. And the council and the National Fisheries Service has been backing them up and saying, okay, we'll record it for you, we'll put it. But what we've done is we've incorporated and published it in the annual report now. Now it's published in a formal report. It's citable. The stock assessment guys can now use that. We've created a time series. It's a short time series, but over time it's going to be a longer time series that they can use to produce the next stock assessment. Okay, so what kind of stuff are they seeing? He showed me a card, so I think I better move. Let's see. Fishery and ecosystem type observations. These are examples over the years what we've heard. Extreme weather events, typhoons, Guam, Sinamai. Actually, we lived through one not too long ago over in Saipan. Tsunamis, American Samoa. These things destroy physically the infrastructure and the boats. These are small boats a lot of the guys use. They don't replace them. You take them out of the fishery. It affects that fishery. Basically, access to the ocean gets impacted. Water temperature changes, things like juvenile recruitment runs, other seasonal runs, definitely affected. Like, for example, last year, Hawaii, across to the Marianas, banner year for marlin. Incredible. Both small and big marlin. Yeah. The albacore fishery in Hawaii, they show up in the fall. They usually run through about New Year's, Christmas time, and then they disappear. Last week or last month, the albacore was still here or there in Hawaii. Guys were catching tons of them. In Guam and Hawaii, the tiao, the juvenile goldfish, oama, they usually show up in the summer. They're showing up in February and March now. So all these things are getting documented. Yeah. And so we use that in the future. Habitat changes. There's areas where there were good crabbing because it's all sand. The sand is gone. Nobody knew the sand went away. Where'd the crabs go? Good question. But it's good to record when that happened. So then the other thing, this last slide, hurry up. Okay, my time is up. But this one is going to be interesting. COVID-19, right? What happened? Everything shut down. Planes ended. All the hotels was empty in Waikiki. Nobody on the beach. This is what showed up when people left. This is about an acre of a kule, we call it, which is a big ice scad. Other islanders call it a tulai. Shows up right here in the Waikiki. Another school shows up inside of the breakwater. These are not juvenile fish. They've been here. They just haven't been here because of activities. Yeah, so we would never have learned that if that didn't happen. Last one, sharks across the board. Interactions have increased tremendously. People are bugging us to do something about it, but what can we do about shark depredation? Bottom fish guys, you catch 5 bottom fish, lose 1 to sharks. Now, catch 1 bottom fish, you lose 5 to sharks. This one here, subsistence fishermen went out of Kona, caught 3 yellowfin tuna, good sized yellowfin tuna. All of them got eaten by shark. Gang. So these are the kinds of things, though, that these fishermen are recording over time and putting it into the annual reports, which we're documenting for future use. Okay, so that was my last slide. Anyway, thank you very much for your time.
Okay, thank you, Mark. And next we have from Hong Kong, Carlos Ruiz.
Hello, everyone. It's my pleasure to be here as a first time and on this 20th anniversary. And today I'm going to share my last 2 years experience as a marine educator. This is the picture from this year with my applied marine science students. Actually, that was after building the their first seaweed incubator. So I work at the Harbour School. It's a private school in Hong Kong, which started 15 years ago, if I'm not wrong, and started with 6 students, and right now we are about 400 students. It's an American school. We follow the next generation standards, and we are very focused on hands-on and experiential learning, and also very focused on the marine environment. Because of that, we are very lucky to have a marine science center that I will introduce you later, and a sailing boat. So the students, we basically teach them from kindergarten to high school, and in every grade, we bring them to the Marine Science Center and we teach them about something related to the marine environment. So, first of all, let me introduce myself. I'm a marine biologist from Barcelona. I did my bachelor's in Barcelona, in the University of Barcelona in biology. And then I moved to the Azores Islands, where I finished my degree in Erasmus program. And after that, after living 3 years in the Azores Islands, working there at the university, I did my master's in Denmark in nature management and specialized in seaweeds, invertebrates, and conservation, restoration. But mostly working as a technician in ecology research, basically scuba diving, collecting samples, sorting out the animals on the lab, so a lot of field work, which I really enjoy. After Denmark, I went to Lisbon to work in marine protected areas for 1.5 years. And a friend of mine was living in Hong Kong, and then he told me about this opportunity, and that's why I'm here and I'm in Hong Kong. So I really like to put together science to make it meaningful and also to educate, to make it something that it's interesting and not just pure academia, pure research. Of course, it's necessary, but for me, what really thrives me and thrills me is to put some action and create something that you can observe a change on it, right? I'm also a passionate scuba diver, and I really enjoy also underwater photography. So, talking now about the Marine Science Center, this classroom that we have at the basement of the school, we basically do a lot of hands-on activities. We have different tanks, from touch tanks to coral reef tanks, research tanks, eel tanks, and it's like a wet lab where we can, in every class, I always try to have like a short introduction and always do some hands-on activities to engage the kids. You can see here, I really like this picture when we talk about water density and the thermocline, how kids really amazed about playing with water, right? Here also, these kids on top, Sam and Oscar, they were doing some research on seaweeds. So they were always around and hanging out with us, and it's like their favorite classroom to come always to visit. And we do a lot of field trips. We are very lucky to have this boat with like a flat deck where we can go out and do a lot of small experiments and taking samples. And sometimes we also go to the beach and just get some trays and put the animals there and teach them about it. So yeah, science could be very boring, but we try to make it fun for the kids. And as soon as you put some creativity and some hands-on experience, you always get a very thrilling experience with them. So that's what we are focused on. So today I want to share this memorable project. That was the first project that I participated on when I started my job in Hong Kong. And basically this was an initiative started by the sustainability department of the school. My good friend Heinrich was planning this project, thinking of me before I moved to Hong Kong, actually. So that's why also I was hired, because I had some experience in seaweeds. So basically, we collaborate. We have what we call the Centers of Excellence, which is the Makerspace, the boat, and the Marine Science Center. We collaborate all together. It's a group of 8 teachers, and made this initiative basically the part of the school. So all the kids were kind of involved. Basically, our goal was to promote some ocean literacy about seaweeds, because when you think about Hong Kong kids, they mostly go from class, home to class. Unfortunately, even though they have a lot of nature around, they are very city people. And when I ask them about what is seaweed, they always tell me, oh, I love seaweed. Yeah, I have snacks here. But they don't know what it is, right? So that was a big eye-opening for them. And here basically I wanted to show all the process. Basically, grade 8 students, they built the structures in the foundry, and then I taught them about seaweeds, basic types of seaweeds. We did some classes on cellular biology. We did some microscopic observations, and that was really interesting for them to see like how complex are seaweeds as well, and how primitive they are, and all the benefits and the physiology. So it was really involving everyone. And yeah, the last part basically was deploying the seaweed farms on different locations in Hong Kong. And after that, high schoolers were the ones who took over the project, harvesting the seaweed and doing some biodiversity analysis, learning how many species were thriving in this seaweed that grow from nothing. Basically, the seaweed season in Hong Kong is from November to April, and you put like a raft with some seaweeds attached, and after a few months you can harvest like 10 kilos from 1 square meter. So it really creates a lot of habitat. And the students, high schoolers, they're here sorting out the animals. That's their favorite activity. It was really beautiful to see them. Usually when they arrive to class, they're all with their phones and they don't talk to each other, no? And then I'll tell them, okay, it's time to sort out the animals from the seaweed that we just collected. And then they sit around a table and they just pick the seaweed and try to find the small crustaceans and sea slugs and sea snails. And then they start talking to each other, right? So it's very it's like a game changer, no? To do like hands-on activities and forget about the screens, forget about all this technology, that we are really attached to. We also did some sustainable aquaculture. I will show you later. We did some partnership with some fish farms. So basically here this project actually covers the 4 strands of this conference, but I had to choose some because we don't have much time, right? But we choose this local species that grows in Hong Kong. And basically, you could see here all the activities that we run through like microscopes with little kids. Then some students also did some research, checking how seaweed absorb nutrients. So they were learning about biofiltering and how this actually this species is very important for grows in eutrophic conditions. I like to put like things like seaweed as a climate hero because, of course, we all love heroes and Spider-Man and this and that, right? But we live on our real world, right? We need to be more aware, right, of what is actually important, right? So here, these are the high school students seeding some ropes in a fish farm. And they also learn about, they did some experiments with carbon absorption. So they learn water chemistry and also community engagement with some local fishermen. So what we achieved so far is that was the first school that we create like a seaweed farm initiative with the community. We empowered 250 students from like grade 2 to high school. Some of them, they were just coming and touching the seaweed and, throwing it to each other and playing around. We also proved that by setting up these farms, we attract a lot of biodiversity. Many species would thrive there and we'd use it as a nursery. Also, the proof of that how much carbon actually can sequester because it grows so fast. It's a very sensitive species. And also how can help to make sustainable aquaculture. So basically, more clean aquaculture, more what we call it's integrative multi-trophic aquaculture. So I would love to encourage everyone else here to ask me later if you want how to apply this. It's very simple. The kids from grade 8 can build these rafts and it's like very simple and they learn a lot. And I think that we could use seaweed as a symbol of hope and possibly work together in the future. Let me show you just a short video of the last. Oh, maybe it's not working. Okay, no worries. I'll share it later. Thank you.
Okay, so thank you, Carlos. Okay, so this is going to be our last presentation for the session because number 9, we didn't send in their presentation. This will be a pre-recorded one, and it's with Jose Marie Escofor, and this person won't be online for the Q&A, but we're going to look at the pre-recorded presentation.
Our oceans are vast. Our oceans are vast, powerful, and life-giving. Yet, for many, especially youth in landlocked regions, they feel distant, almost invisible. At EnviroVision 2050, we are changing that story. Hi, I am Charu. I am the co-founder and curator of the EnviroVision Green Leaders. Project Green Leaders connects youth, no matter where they live, to the heart of ocean protection. Green Leaders began with a personal journey. I had to leave Delhi with my daughter due to rising pollution levels. We were fortunate to move, but our friends back there were still suffering. We knew we had to be part of the solution. That is when EnviroVision 2050 was born. We knew every action counts. We believe that protecting the ocean is not just the responsibility of coastal communities. It's a global call to action, and everyone is responsible. Our Green Leaders program is a youth-led, action-driven program which is endorsed as a UN Ocean Decade activity. We reimagine ocean literacy through a transdisciplinary blend of science, storytelling, art, and action. Why it matters? Well, pollution knows no boundaries. A plastic wrapper in a city park can end up in the ocean.
Rivers carry plastic waste from far inland and send it right out to sea, where it accumulates. But how does this plastic and other litter get into the rivers in the first place? We're on a mission to find out.
Climate change, biodiversity loss, these all affect us all. Our special focus? Youth in landlocked areas. They are inspired by ocean heroes. The work they do, understanding how even a single person can bring about a change. For many of our young learners, the ocean is not a memory or a view. It's still a mystery. They have never seen an ocean. So, we bring the ocean to them through dioramas, videos, and through stories in the language they understand, making it deeply engaging. Inspired by the National Geographic explorer mindset, we weave oceans into their everyday lives, in classrooms nestled far away from coasts. We take them on field trips, co-create art, poetry, and craft. Engage them in youth fashion initiatives that promote sustainable clothing. Through social media campaigns, they amplify their voices to the world. We even translate resources into vernacular languages to ensure no voice is left unheard. This is our transdisciplinary approach where science meets creativity. Tradition blends with technology, and action is woven into identity. We help students see how the ocean connects to what they eat, wear, believe, and build. And that even from 1,000 miles away, they shape the ocean's story. Taking the baby steps ahead, we have reached out to more than 45 schools with 45,000 people and 45 projects already undertaken, all driven by youth. From e-waste repurposing to community campaigns, our impact is growing. We are inviting schools, colleges, universities, and the change makers from across to join us. EnviroVision 2050, empowering the next generation to protect our ocean.
So can we get David, Mark, and Carlos down for the Q&A? So we have about, it's 5. That was the last one. Okay. So we have until 4:20. No, 5. Let's see. I think we have 20 minutes, and then we have about 10 or 15 minutes break, and then we have the movie night. So we will start. Any questions?
I have a question for Mark and for Carlos.
Right there.
So for Mark, I really enjoyed your talk. I wish they could do that in every country. And I was interested to know, how do you involve fishermen and how do you create a relationship where there is no, it's a good relationship, like of collaboration and not of antagonism.
Yeah, so the act itself, the authority requires us to have these different advisory groups to the council itself. The council is made up of 16 members, half of whom are government agencies, the Fish and Wildlife Service, the National Fisheries Service, Coast Guard, State Department. The other half are community people. They're nominated by governors and appointed by the Secretary of Commerce, so they serve terms. So they're fishermen, and if they're commercial, recreational, subsistence fishermen, they're on the council. Yeah, they're also university people, different types of groups. They have NGOs that sit on the council. But there's 3 groups that we're required to maintain. One is a scientific and statistical committee. And that body has experts from all over the region and all kinds of disciplines. So they advise the council on all sides. The other is advisory panel. That's the fishermen group. And that can be subsistence, recreational, commercial fishermen. And then we're required to have a fishing industry committee. And that's the larger scale commercial industry, fishing, seafood distributors, those kinds of people. They all advise the council independently, And so we work with them constantly. They're integrated in the process. That's how we do it.
Thank you. And for Carlos, thank you for your great talk. I was interested to know, how do you teach carbon sequestration to the kids? Like, because that's very difficult to teach, so how do you do that?
Well, basically, it was more about carbon absorption, basically. So we had a tank that we diffuse some CO2 with a CO2 tank and one without. And then they would measure the pH and they will do some calculations and they will see how much carbon, how the concentration of carbon also makes the seaweed grow more or less. So that was how we got. We did different experiments, one with nitrogen, one with CO2, and one with nutrient recycling using grazers. So that was how it worked.
Thank you.
Thank you.
Hello. Yeah, thanks for all your. It's amazing how we've heard a lot today, and I was thinking, oh, I'm going to take it more, and we just do. It's great. Fantastic. Thank you for all your presentations. But I was just curious with all your work and thinking and saying you're about to retire. Are you creating materials from that talk? Is that where you were going with that? Or in terms of, I was wondering. Because I know you like art and painting. So, so I was just wondering where you were going with that thinking.
I make this by myself. I collect a lot of the information, simple, very beautiful chart, and I put it together on a small box. Then one time it come and I saw this, I make this for reward. Everybody answer my question correct. I send it to him, and also I send it with the idea, because of the idea, the word said is forest is the lover of the ocean. Then my friend say, river is the matchmaker. So put it together, forest, river, community, ocean. So I make a small demonstration. Anybody say this is very, very beautiful, right? We live a harmony relationship with this. But we start to destroy it, or push it down. And you see the animal is disappeared, the wood is gone, and the floating wood in the ocean become increasing till the end of the. You got a word like this, nobody like this, but we can do it once again. Restoration, put it back, slowly put it back, so it becomes more beautiful again. And I showed you this. Power is right on our hand. So everybody can understand it with a very simple creation. And this too is asked by Jens, the head of the institute, see this, and he wanted to do her own. This is we call the trash. See, that's more beautiful, clean city, clean community. Nothing wrong with the community, nothing clean ocean, but you start to make it dirty. You'll see more and more trash in your community, right? And you see more and more in the ocean. Okay? So when you put it down with a lotus, you got the dirty city. You got the dirty city and the dirty ocean. So when you put it back, push it back slowly. There's the backwards process. The city becomes cleaner and cleaner, so is the ocean. So it's a very simple idea, a creation, and you can send it to your friend. This is the postcard. Send it to your friend, share your idea. That's what I told. We have to rethink what we are doing. Maybe you don't have much endless money, but if you think creatively, you make something great and spread your pass your idea clearly and very interestingly. This is my idea. Thank you. And I don't want to bring it back to my museum. Please share, okay? Come to me after section.
David, thank you. I'm retired 6 years. You are going to retire. The one word I see that I've used, rethink. For 50 years, I've been involved in education and work. It's not working. So we need to rethink what we're doing. Reduce, reuse, recycle. No, we need the R of rethink, respect, responsibility. And I enjoy that, and I hope that people that aren't retired remember that word to rethink, because we really need to change what we're doing. And I'll be talking about change tomorrow. I just appreciate what you have to say, because I think we all need to reevaluate what we're doing.
Yes.
So thank you so much.
Mike say what I want to say. David leading Taiwan marine education for past 25 years, and then enthusiasm until now. There's so many challenges every day and every time, but he keep his patience, influence so many people, and retire is another journey, and no position, no power, no money. Of course, everyone here, so many people is similar situation, but how to cooperate, how to do that, because we contribute ourselves, and that is the hot season, and that is more capacity, but retire lost anything, zero. We're always thinking about that. We will change our position, we will change everything, but connecting everyone is a network of power. Sometimes I get the message that who is not a high title, they are not important enough. And I'm thinking, what is important? Important is the title, general manager, or anyone is big title is being important. So I want to congratulate for your contribution to the marine education society, and do a lot of things. And people following you, you have your strong network. And not easy for changing, maybe we were for mine, but we have so many senior, especially Ipmen community members, so powerful. And after retired, it's not easy but important. So my question is to Carlos. In the province and long journey, what can you learn from the elderly, from the very reachable, knowledgeable people to enhance ourselves, to connect each other?
Good question, right? Yeah, actually, thinking about the first talk from Peter this morning, no? Yeah, we are a big community here, right? We are all related to the ocean. We have the same goals. We just want to live like in a healthy planet, right? Keep enjoying our life in this healthy planet. But yeah, somehow many things have to change, and I think we are in an era of change, right? We have achieved some limits, and the only way to cooperate, to have a better place is by acknowledging that we need to work together. We need to somehow forget about our egos, and be more humble, right? And also respect the older generation, right? And learn from them. In Spain, we have also a very traditional culture, I would say, in terms of family. So I spend a lot of time with my grandparents, for example, right? And I learn a lot from them. And somehow this is losing. I feel like nowadays families are very nuclear, and there's not. Well, I think there's a Chinese proverb, right, that it says that you need a village to raise a kid, right? So yeah, we need a city to clean the ocean or to make like a big change, no? I'm teaching these kids, and they're always coming to me and asking me questions about how to change and what to do, right? And last week I had a chat with a student because he was like, "Oh, you, Mr. Carlos, you have to do something, you know?" And I was like, "Well, maybe we will do something together in the future when you graduated and you go to university and this and that." But I'm not. I cannot do anything on my own, right? I need a team of people. We need to work together to achieve things because, for example, this project about the seaweed, we work together, different departments to make this possible. If I would be on my own, it would be impossible because I have to take care of the tanks, I have to teach classes, I don't have time, right? So yeah, I guess that there's very important to put all the community together and listen to the experience also of the ones that are here before us and have some knowledge, right? So yeah, I don't know.
Do you guys have any questions? Do you guys have any questions or comments for each other? Okay. Okay. Well, did you get this video? I think we can show the video you weren't able to show at the end of your presentation. We'll show that, and then after that, I think Ray, maybe you could talk to people about where to go for the video now and stuff. Yeah. Okay. Okay.
I can plug in my computer maybe, or because I'm not sure.
Yes.
I just noticed there's just the plastic problem, the bottle problem. It's all related to water. Like in Barcelona, there's so much bottled water, and I go to different countries, and here in Taiwan, there's so much bottled water. I can't drink from the tap of the hotel. And just thinking there's hundreds of thousands of people doing the same thing with bottled water, which we know is like microplastics and stuff going into our own systems because we can't often go to a tap because it doesn't have proper filtration systems, and which in turn, of course, is going into our oceans. And man, do we have a bottle problem, and especially in, second world country, in the first world country, a bottle problem, but you can imagine in all the second and third world countries, and it just seems endless. And I'm just trying to think about your solution and stuff, but I'm speechless. I'm overwhelmed by if we can't fix our water pipes, how are we going to stop the bottles from flowing?
I just propose an ideal concept. I know I'm not denying the importance to tell the people to don't use the bottled water, the importance of this. I think that's important. But what I want to emphasize is we should do something good in daily. So when I'm not encouraging to do the beach clean up, I will emphasize they were doing to do not use any plastic thing in your daily life. I will explain this idea because eventually it will go to the ocean. That's my idea. So we have in Chinese say 源头减量. That means don't use any plastic. So there was no plastic recycle, no plastic repair, no plastic reborn, no plastic. There's no other question is. But if we can see this have this profound effect on this, we should provide the idea of this, not encourage people to go to the beach to clean up the beach. Whatever we clean up the beach, you will always get a lot of plastic. You never get any. Then you frustrate. My lot of friends frustrate because whenever they clean out the beach, after several days or even several weeks, the trash come back again. And you say, oh no, I don't want to do it anymore. But if we can do something in daily life to reduce the plastic at all, we don't use it at all, then we don't have the plastic problem. So that's what I say. See the big picture, identify the key question, then we work on it. I think it will be better than we encourage people to clean up the beach. This just the framework. Because I just mentioned, if the idea is too big, people will say, oh, it's too big, it's beyond me. Government will do something about it. Something great people will do something, not me. But if we can see nobody is not included, everybody is included. Then you will see, I will reduce plastic. I won't use plastic as possible as I can in my daily life. And if everybody do that, you can imagine that there's not a plastic thing will disappear. Even you will affect the industry because they have to modify their product, right? So that's my idea. So I propose a framework. I emphasize we rethink what we're doing. We rethink what we are passionate. Everybody is passionate. Here, everybody is passionate. Who is not passionate at all? We are passionate, but we have to limit the power, limit the budget. We have to think clearly before we do something. That's my idea. Thank you.
Thank you, David.
Please come to. I don't want to bring them back to my museum again. Okay, thank you.
Okay, so we're going to show Barnes' video real quick, and then we'll begin.
Yeah, they allow us to have the farm, but only for a few months. So much less. Incredible.
These two seaweed farms, and here we were checking with Kenny.
Here's water is so clean.
One of my passionate students from grade 7.
Yeah, the water is quite clean, right?
Yeah.
The animals. And
some places in Hong Kong get very
see the amount of seaweed just hangs from that. And we collect some, and we bring it to the school. We do the experiments there, and basically we also harvested, sun-dry it, and
probably some boat attached to it.
Put in the soup, and yeah, basically they see the whole process. So right now, after this is the 3rd year that we're doing it, all the kids now know why seaweed is important and all the benefits.
Look, they have this.
How is it important for the habitat, for little fish, little crabs. That's the part that they enjoy the most, actually. Looking for animals hanging there in the seaweed.
We can make it a little bit
So
bigger.
the problem in Hong Kong is that the growth has been so disrupted in terms of competencies between animals that it doesn't grow anymore because there's too many grazers on the intertidal zone. And that's why with these structures, actually, we are increasing the amount of seaweeds that used to grow. So it's like a way to kind of bring back the initial ecological status. Thank you.
Yeah. Okay, thank you. We have a very good conversation. 你帮我看一下外面他们楼上有没有人下来订公告。So we have a quick announcement, and we update the new information about tonight's the video night, and we will be the same venue. The video night will be the same venue as the Marine Science College. We need to walk there, but come back. We will call some taxi and back to hotel. And we're supposed to finish about 8 o'clock. So we'll start 6 and prepare dinner there. So you can go there and walk there about 10 minutes of very good sunset. no, you don't have to jog. A beautiful sunset. So we walk there, and then just there, walk there 5 minutes or 10 minutes. 5 minutes, I think about 5 minutes. And next night. So today we will have the videos that is using one is from Taiwan. It's National Geography. It's very good, and let you know Taiwan is actually is very important of the south is what's that? It's Australasia, and then there's the sail back to the homeland. And actually there's four edit, but this is the first one, and the second one will be Peter. It's the film. It's about the tsunami, and then 2 from Hawaii. So will be about 1 hour, and then will be about 30 minutes after screen discussion. Okay, so welcome everyone can join. This is very good opportunity. You can see how Peter doing. Next time you do is United Nations Ocean Decade, right? It's a film, the documentary night is very good. And second, it's about the Takao Declaration. If you still not signed it, I hope you can keep your word here. It's very important that for you to initiate. And if you are not taking the certificate of attendance, and please check it. And if you not your name there or your name fault, and yes, we try to do. Yeah. So I hope you have a good day. And tomorrow is the final day. We have a final section from Mike, and we also the shuttle taxi. I encourage you come together. But if you want to meet together, it's A20 Holiday Inn Hotel, and I encourage you to come and directly. And tomorrow we're morning section, and the afternoon is the key. Is our Takao Declaration announcement and the press conference. And you can see the press conference, and that will be very important for us. We do some rehearsal. Tomorrow we will do some rehearsal, and I hope that can influence more people. And then finally, I hope you can share more information. If you share information, and I think anyone do not get my email, and I think more, no? Yeah, yes. And if you get my email, I hope you can post more media, and then more people know what you are doing, and more people know about the initiation. And yeah, we need to know about the inference, because boss asked me what is the inference. I cannot answer what is the inference. So I appreciate someone respond and share about the Minister Guang. Minister Guang post information from her web her Facebook. So I hope that we can have some comment or something. It's okay. We want to emphasize the inference to the policymaker. Tomorrow, the same. We contribute a lot, but we need that policymaker to know what is our inference. So see you tomorrow, and see you tonight to the video night. Thank you so much.